In this video, we'll generate the trend line and the trend line equation of the probabilist Hermite polynomial from 0 to n. So our values of n is from 0 to 10. So we'll generate the polynomials from degree 0 up to 10. The equation of the Hermite polynomial is y equals a times x to the power n minus k, where the value of k is from 0 to 0.5 n, and the coefficient is this expression. So our k values will be sequence of n times 0.5 plus 1, one column starting from 0 incremented by 1. So that our value for n at 10 is 5, 1 half. And we'll use the series sum to generate the expansion. Our formula, series sum of the x values raised to the power n minus 2k. So starting with n, and the interval is minus 2k. So minus 0, minus 2, minus 6. So the interval is negative 2. And the coefficient will be this range. This is the coefficient a. So here we have the trend line and the trend line equation of the Maclaurin SERIESSUM expansion, also the Hermite polynomial. Next, you fill up the coefficient column. So RA formula, starting with the numerator, factorial n, times negative 1 to the power k. So that if this is empty, this should be 0. So we correct this. So if k is empty, this should be 0. That's k if empty is 0, otherwise calculate. So that's corrected. We continue with the, the denominator. So divided by quantity, the first term, factorial k. The second term times factorial n minus 2k. So factorial n minus 2 times k. The third term. The third term is 2 to the power k. 2 to the power k. So here we have the trend line and the Hermite polynomials in the polynomial to the 10th degree. We'll calculate these coefficients, regression coefficients, using LINEST. To do that, we complete the 1 comma x matrix. So we set this aside, and this is the 1 comma x matrix. So RA formula of the x values raised to the power 0 to 10. Sure. Now that we have the 1 comma x matrix, we use LINEST to generate the regression coefficients of LINEST data y and data x. So we'll compare the regression coefficients with our polynomials. So starting from 0 at n equals 0. N equals 0, the Hermite polynomial y equals 1. 1. N equals 1. Hermite polynomial y equals x. That's x, 1x. N equals 2. Hermite polynomial y equals minus 1 plus x squared. Minus 1 plus x squared. N equals 3. Hermite polynomial y equals negative 3x plus x cubed. Negative 3x plus x cubed. N equals 4. N equals 4. Hermite polynomial y equals 3 minus 6x squared plus x to the fourth. 3 minus 6x squared plus x to the fourth. At n equals 5. Hermite polynomial y equals 15x minus 10x cubed plus x to the fifth. 15x minus 10x cubed x to the fifth. At n equals 6. Hermite polynomial y is minus 15 plus 45x squared minus 15x to the fourth plus x to the sixth. Minus 15 plus 45x to the x squared minus 15x to the fourth plus x to the sixth. N equals 7. N equals 7 is minus 105x plus 105x cubed minus 21x to the fifth plus x to the 7. So that's minus 105x plus 105x cubed plus or minus 21x to the fifth plus x to the 7. X equal at n equals 8. N equals 8 is 105 minus 420 x squared plus what 210 x to the fourth minus 28 x squared plus x to the 8th. That's 105 minus 420 x squared minus that's 210 x to the fourth minus 28 x to the 6th plus x to the 8th. At n equals 9. N equals 9. So 945 minus 1260 x cubed plus 378 x to the fifth minus 36 x to the 7 plus x to the 9. N equals 10. N equals 10 minus 945 plus 4725 x squared minus 3150 x cubed x to the fourth plus 630 x to the 6 minus 45 x to the 8 plus x to the 10th. This completes the use of the Taylor-Maclaurin series sum and Linus polynomial regression to generate the probabilist Hermite polynomials.